Good day everyone, and welcome back to the X Explorer for another video. This one is really going to be a short one, probably 10-15 minutes tops. So I said that I'm going to come back with part 2 on building the RF amplifier kit that I built for my friend Vlad, Yankee Oscar 5 Bravo Delta Lima. So this is an RF amplifier designed for CW only. It might be modified for SSB, but it won't have good results, so stick to CW. 12 volts, it should have somewhere around 30 watts I believe on the 20 meters band, if I remember well. And yeah, I said I'm going to come back with a video when we'll do a power test, and also we are going to do the harmonic suppression test just to make sure that it works fine. And I sent to my friend Vlad an RF amplifier in good working condition. Now we're also going to talk a little bit about some details regarding the inductors for the low pass filter, and yeah, some important details actually. And I think that's it. So Vlad, this version is for the 20 meters band, and Vlad is going to use it with a QCX Mini. So I said in the past video that I'd like to possibly order one for myself because I really like it, but since it's just for CW, I decided to actually seriously thinking to build my own RF amplifier from scratch. And if you have any good schematic for an RF amplifier, I only have three conditions actually, but I would honestly prefer something that gets the maximum power output at 12 volts. That is one condition. The second one is that it has to work on all the bands from 160 up to the 10 meters band, because I'd like to put a switch and switch the bands and basically the low pass filters for various bands depending on what I'd like to use. And the third condition, it has to work both for SSB and CW. So yeah, that's it. So if you have any schematic that you think I might be able to use and build a good RF amplifier, oh, and the power output something around 40-50 watts, but yeah, feel free to email me the schematics. I'll be happy to try them on and see if I can build my own RF amplifier, especially knowing that I have my friends from PCBWay on my side, and I can design some really nice PCB boards that you could possibly order from PCBWay and build your own RF amplifier from scratch. So yeah, without wasting any time, let's carry on with the video, but of course not without saying thank you to my friends at PCBWay for always sponsoring and supporting the DX Explorer channel. Do you like building your own homebrew radio gear or other electronic circuits? Now you have PCBWay. With excellent PCB prototyping services, PCB assembly, SMD stencils, CNC, 3D printing, and a lot more services or products for you. All you have to do is to open your account on PCBWay, use the software of your choice to design your PCB board, upload the Gerber files, pick the desired options from the technical details panel, and place your order. Soon you will receive your professional and amazing quality PCB boards that you can use for your projects. As I'm always saying, PCBWay is the way. So I said that I'm going to return with a couple of details regarding the toroids, and if you had the chance to watch the video when I was building the RF amplifier, you probably remember that I had a confusion between respecting the number of turns that it was given into the manual, or the inductance, which was also written over there, and I decided to go for the inductance. So that means that I did not respect the number of turns, and it was still a confusion to me, so I decided that it was better to contact Hans, and I have to say a big thank you to Hans from QRP Labs for the quick reply. And he also told me that I should respect the number of turns and make adjustments with the distance between the turns on the toroid in order to get the best results out of this RF amplifier. So that's what I'm going to do right now. I'm going to take the toroids out really quick and rewind them again with the correct number of turns, solder them back together, and after that we can carry on with the rest of the power test and the harmonic suppression test, and then I can pack it up and send it to my friend Vlad so he can finally use it. Okay, so in order to properly do the testing according to the instructions from the manual, first thing first is that we're going to go into the menu of the QCX Mini. Make sure that the keyer, we're going to go in the keyer mode, is in straight mode, and also we have to put it in practice mode and save the settings. Alright, and now we're ready. So what we're going to do is to connect the QCX Mini to the RF amplifier. So basically the output goes into the input of the amplifier. You connect the PTT cable to the amplifier as well. We make sure that we connect the key and we're ready to go. So I'm not going to do that on screen just because it takes a long time, and I said that I'm going to go under 10 minutes. But let's jump really quick to the amplifier itself. So once you turn it on, make sure that the trimmer resistor, it's all the way anti-clockwise, and that's how we're going to start making the tests. Now on the power supply, on the input, I also have connected my multimeter to measure the power consumption, basically the current, and you have to measure the consumption when you're going to start transmitting with the QCX Mini in practice mode. Again, I'm going to put an accent on that, so the QCX Mini has to be in practice mode, and you measure the current consumption that you have with the trimmer resistor all the way anti-clockwise. Mine was 83 milliamps, exactly as it was described into the manual. So then you will have to slowly turn it clockwise until it goes over 83 milliamps, and mine, in my case, it jumped over 85, I think, 85 and then 91 straight away milliamps. So you have to go back to 83 milliamps until you read 83 milliamps on the multimeter basically, and then go back again clockwise with very, very fine adjustments until you find that point when it jumps over 83. Then probably you might have to repeat this a few times until you get exactly at the point when you're like right between 83 and 85 milliamps. So you still have to keep it on 83 milliamps, and that's what I did. Again, I'm not going to do it on camera just because it took me quite a bit of time, and I promised the video to keep the video short. But yeah, this is the proper adjustments, and the only adjustment that you have to make to the amplifier before using it. And then what we're going to do first right now, it's going to be a harmonic suppression test, just because I modified the inductors for the low pass filter. As I was saying at the beginning, I wasn't sure about the way they are, and yeah, I want to make sure that I don't have any harmonics. And after that, towards the end of the video, we'll do a quick power test, and I think we're good to go. So in order to do the harmonic suppression test, and I will use the same thing for the power test, I have this RF dummy load / RF tap, because I have two in one actually. I built this one some while ago. You have the video, couple of videos back. So this is the tap, basically the RF tap, RF sample that goes to the tiny SA, and here I have minus 40 dB of attenuation, or actually 40 dB of attenuation, because definitely it's with minus since it's attenuating the signal. And on the other side, I'm not sure if you can see, I have an output as well, straight from the dummy load, going for the RF wattmeter to measure the power output. And yeah, now we're ready to do the harmonic suppression test to make sure that everything works fine. Alright, so in order to do the harmonic suppression test, what I did, I put my power supply on the maximum voltage, which is 15 volts, to make sure that I have the maximum output power on the RF amplifier. And I took the QCX Mini out of the practice mode, so right now I'm going to start transmitting. And as you can tell, we have a very good signal, very clean signal. So no stress on the harmonics. So the low pass filter works well. I guess there are no adjustments needed. So right now let's do a quick power test, and I think we're done. Okay, so in order to measure the RF power, I connected my homemade RF watt meter into the output design for the RF watt meter for my dummy load. I'm powering the amplifier with 15 volts, and I think my QCX Mini, it's powered with somewhere around 13.5 volts. So the power output that I'm measuring right now, but of course I cannot be 100% exact on the power output that I'm reading, just because I had to retune this one for 100 watts. So basically where you see 2 watts, it should be 20 watts in our case right now, but usually this one is designed for no more than 10 watts. So I had to do some adjustments in the back in order to be able to measure this amplifier, but it shows me just a little bit over 20 watts. So I'm thinking that if you power it with 19-20 watts, as it says in the manual, you're able to get the full output power of 50 watts. But I'm happy it works, and I think it's ready to send it to Vlad. Okay, my friends, so that's it with the amplifier. I'm ready to put the cover and put it in a box, get it ready to be shipped to my friend Vlad. So I'm happy. Again, it was one of the most difficult projects that I built so far, and also my first RF amplifier, but difficult just because I don't have the tools necessary to measure power outputs that are so high. And yeah, I definitely need to buy an RF power meter that is more exact, that will work both for HF and VHF, even though I do like my homemade version for the little gear that I'm building. But if I want to do precise measurements, I clearly need some properly made RF power meter. Well, probably that will have to wait, because right now I don't have the budget for that, but I'm happy that at least I got to finish this one. So I'm ready to send it to Vlad. And for those of you that got to stay all the way at the end of the video, I'm going to present to you the project that we are going to finish working on tomorrow. I'm going to post another video, and this is also a little present for my friend Vlad, a CW SPI transmitter. I called this one DX20, but it's actually the 20 meters version of the minimalist CW transmitter that I presented some while ago. So we're going to put this one together and show you how it turns out and how it works. So anyway, thanks so much for watching. I'll see you tomorrow in the next video. Until then, 73, and have a happy weekend.